today we are going to discuss some corpus other than the text. Okay, already we downloaded some of the documents uh, from the NLTK package, right? So in that text one to text nine, those text are general documents, the combination of some sentences. But here we are going to see with the different varieties of text. Those texts are like this. Okay, those may be sentiment analysis or the chart boxes or some of the electronics devices. Okay, electronic related, poems related. So for a different purpose of works, we use a different format of the languages. For that purpose, how you access? Okay, how can we access these type of text using this NLTK? We'll see here. The first one is so Gutenberg and its file IDs. Almost it has this NLTK as 70,000, not 25,000. 70,000 electronic books you can get it from this website, Gutenberg. What are those? Okay, what is the length of those things? And what are the file IDs? Those we will see here. Okay, generally, the practical work in the NLP, we need to access more number of documents at a time, not a single document at a time. So that's why you need to compare some of the common words or some of the keywords among so many documents at a time. So that's why you need to access the thousands or lakhs of documents at a time for your experimentation purpose. But here the document types are different. Some documents generally consist of the chart data. It is generally with the different persons with the different SMSs and with their details also. So based on the details, based on the age group, based on the gender group, okay, what type of data they are charting with each other, all those we will see here. First of all, we are going to get this Gutenberg documents. That website consists of 75,000, 70,000 electronic books documents. And what are those names, file names, and how many files are there? All those we'll see here. To access this, we use this Python interpreter to load all these documents from this NLTK package. Then ask to use this nltk.corpus.gutenberg.fields. So it means here, after loading this one NLTK package, it has a flexibility to get these corpuses from this website. Okay, Gutenberg website. Similarly, there are so many websites. Generally, it does not contain the entire data. It fetches the data from these websites. When you make this type of sentence, syntax is like NLTK is a package. In that, corpus related functions you should activate, and those functions retrieve this Gutenberg data from the websites and their fields. So, how many documents are there? Those will display in front of you with their names. Suppose after importing this NLTK, now I am executing this command nltk.corpus.gutenberg.field. So that field, uh, yeah, that file ID is different. Srikant, Srikant, చెప్పు శ్రీకాంత్. Hello. The Gutenberg generally it has 70,000 free electronic books. You can get it from this website. And then redefine the log names, the file names. Otherwise, every time entering all these stin hyphen mr dot, these are all, it is a long process. That's why you make it a simple. So that's why you redefine long names of the text using this Python. Python provides another version of the important statements as um, redefining things. So same thing already it is okay. NLTK.corpus, you import this Gutenberg, and Gutenberg.fields gives you the total number of file IDs, gives you the total number of files. These are the total number of files. And what is Emma here? The Emma, I am renaming that as Emma is equal to Gutenberg dot words. Already Gutenberg you imported from this corpus, and from that Gutenberg you are fetching the words from this. So from next time onwards, just use this Emma. That's enough for all other operations. So to display the other information about each text, okay, the text involved in this corpus, just write a short program by looping over all the values of the file IDs corresponding to this Gutenberg, and so that you can fetch a common word or common sentences involved in so many documents or text involved in this Gutenberg corpus. And from these, the file identifiers generally listed as we have seen earlier in the above, and then it computes the statistics for each text. So these program generally, we are going to see that one involves, it displays the three statistics for each text, each corpus text. One is average word length, average sentence length, the number of times each vocabulary item appears in the text, and the average. So for not only these statics, you can make any number of statics, but I created that one here like this. For the file ID in Gutenberg.fields, so I am checking the file ID for each file ID. Okay, so total number of file IDs you can see here. You can make it as file ID, len of file IDs. Okay, already we have seen here. We'll see. Uh, so here number underscore characters. So I am calculating the length of Gutenberg.raw file ID. So for file IDs, each file ID, I am calculating the length of this Gutenberg raw file IDs. Now, total number of characters you can get it. And similarly, the len of this Gutenberg dot words, total number of words, calculation. The number of sentences from each field, file ID, you are calculating. And these are my own name I created. And the len of set of w dot lower per w in Gutenberg dot words with the file ID, you can get it. So now print the first one as int of uh, the number of characters. So this it fetches the number of characters divided by number of words. It fetches this one from all the documents or the file IDs, and that is one you have to print it. So here it is a 4. That is total number of characters used in Gutenberg in all file IDs divided by total number of words gives you it is 4. Actually, in English text, in any document, if you see the average length of the word is always equivalent to 3 approximately, right? Mm. And similarly, the second line, it is a print of second one. What is second one? Int of number of words given number of sentences. How many words used in this Gutenberg and divided by number of sentences for each file ID, it is 21. And then uh, another way of printing this int of number of words given by number of vocabulary. So that is here 26 for the first text, first file id. And what is the file id? So this is the file id, Austin Emma. So that means based on this for loop, for each file id in the Gutenberg fields, you need to print all these information. That information is average characters used, average numbers used, and average words given uh, per number of vocabulary, and this file id name. This is the file id. So total, if you count it, total number of file ids are 23. You can see this. I'll show you this coding also here. This coding I'll show you here. So here it is a Emma. So I imported this one from the corpus of this Gutenberg. All the file IDs are this, and then I renamed it as Emma dot this one. It gives you total number of len of this Emma is 1,92,000, and I created with a shorten as Emma. Now you can make any operations on the short name. So Emma dot concordance of suppose along word. I'm checking how many sentences comprise this along. So only four sentences are there in this Emma text. And what is the set of Emma? So the set of Emma, that is unique words used here in this Emma, is this one. And also what is the length of this Emma? Len of set of whatever we use above, just you copy paste it. Set of Emma. It is Emma. Yes, Emma is, we can check it. So 7,000 unique words are there. 7,811 unique words are there. And then from NLTK corpus, import Gutenberg. And now the file IDs are this. Already we checked, I hope. These are
Sir,
the file. Yeah.
in this Gutenberg, we have the 70,000 books, right, sir?
Yes, yes.
Like, what if we want to add one more book in that?
You cannot add it.
Okay.
Okay,
So it's like
the
built in,
fellow,
sir.
the fellows, the fellows who organizes this one, they can add it.
Okay, then what if we want to, like, we have the one book, then in that book only we want to
You
check
can
the
search
length.
it. You can go to the website and you can search it.
Like, we can create another separate book, sir. Only book, not from the Gutenberg.
If you want to fetch it, if you want to fetch the book from this website,
No, sir.
hmm.
If I want to create one book separately, then can I do that?
We'll see it. Our data also will fetch it. Don't worry.
Okay.
Okay, it is only starting. Okay, starting position. Actually, our work is based on our own data sets. Okay, not on the predefined data sets. This is only as a warm up for hands-on practice. Okay, you should know all these concepts. Otherwise, directly you cannot go there, right?
Okay, sir.
That's why we are getting the information how to get different varieties of data sets. So this is one type of data sets. The next one we will see the social media data. Okay, how to get how you fetch the words, what type of sentences are there, what type of groups are there. Those we'll see. Don't worry, everything we will see. Okay, is it audible?
Yes, sir.
Yeah, yeah, right. So whatever it may be, concordance already we have seen in the previous sections. Now, uh, okay, this is different words, unique words. Else, this is the total number of unique words. Directly you can check it. And these are the field IDs. What is the number of field IDs? It may be 23. And right, I renamed it. Now, okay, already how we printed with all these average values, total number of characters, total number of words, total number of sentences, okay, and the field IDs. And what are the number of words? The number of words, what is that here? Here, it is the number of words. What is the meaning? Len of Gutenberg dot words of file ID. So the total number of for each file ID in this Gutenberg fields, you are gathering all these file ID values. It is 19 lakhs something. Uh, uh, okay, 1,54,000 880. So like this number of characters, 71, 7 lakhs of these, and the number of sentences, number of vocabulary. And the second one is important here. This is same as like a previous one. Now we'll see the second one. After Gutenberg, there is another type of the data you have to fetch for your laboratory work or hands-on work. That is web data and chart data. Okay, the web data and chart data in the olden days, they gathered and made a repository for experimentation purpose. That is we are using here now. Okay, in those days, 20 years back, the website and the interface of these websites was not that much good. That's why only for experimentation purpose in those days they gathered and fetched everything from the websites and named it as the web and chart text data. So generally, this analytic is a small collection of the web text, includes this content from a Firefox discussion forums. It depends on this XML and the conversations. Okay, overhead in the New York. Okay, this is only related to New York movie reviews or discussions, and Pirates of Caribbean's discussion, and the advertisements discussion. Okay, and wine reviews. Okay, this data gathered and they made it as this one. Okay, this web and uh, chart text repository or the document. Generally, it is collected originally from this Naval Postgraduate School. Okay, we call it as also NPS data. That NPS data gathered for research purpose. In those days, it was evolving. Okay, 20 years back, this NLP, not like the computer vision. Just that was evaluating position. So for this research, they named this repository as NPS, and you can get it this repository related sentences automatically, automatic detection of internet predators data, and this corpus contains over 10,000 posts. Okay, the SMS post or the reviews, whatever it may be. Okay, the communication or the reviews about so many things we discussed about New York, about movies, about wines or drinks, about advertisements, all those. So this consists of 10,000 posts. So anonymized by this replacing usernames with generic names of the form user NN, triple N. And manually you can edit it by removing other identifying information. This was organized into 15 fields, 15 files. Those files are, I'll show you below how they organized, where each file contains several hundreds of posts collected on a given date, and based on the age specific, gender specific. Okay, all those that type of data they named with different file names. So that is one group. Suppose teens and are below 20 years, they communicated with the different SMSs or charts. They gathered that one under these teens with a particular data, a particular date, and the chart rooms also. Based on that, we will see. The convention here is the file name generally consist in this how they are organized. The date, that is the first one, it displays. The second one is a chart room, and then number of the posts. Okay. That here you can see this one 10 9 20s underscore. This is 706 post.xml. So it means it consists 706 posts gathered from the 20s. That means 20 means age group. Chart room on this 10 19 2006. Okay, there are 706 posts are there. Those you can get it. Whatever posts are there using the Python syntax. Suppose here, if you see this one from NLTK dot corpus, import NPS underscore chart. NPS means National Naval Postgraduate School Related Charts. Those charts imported from this NLTK corpus, and I'm naming this one for a particular file as because for experimentation, I named a chart room. Chart room is equal to nps underscore chart dot post. It means this is a function as chart dot post of this one. This object. This object consists 20 age group, and 10th and 19th, 19th, 10th month with a 2006. So this is not a specified the year here. And there are 7 or 6 posts, and this will gather the information based on. Suppose I want to see the 120th chart, okay, what they communicated here from this corpus. So they chart like this. I do not, okay, want hot pics of a female. I can look in a mirror. So this type of chart they posted in this 123rd post in this chart room. Okay, on this data, on this post, on this date. So like this, you can get the information from any type of. So to get this chart type of the data, you have to use these functions dot post or charts, all those. Right? It is one thing. Next is the brown corpus. All of you know this brown corpus. This was the first million word electronic corpus of English created in 1961. And all of you know this, okay? At the Brown University. Based on this, you can also gather different varieties of sources. Those sources almost they made it as the corpus of 500 text, okay, documents, and the source have been categorized in genres such as news related, editorial related, and so on. Suppose we will see some of the operations on the news or editorial. Check this example as for each section of the brown corpus, you can access the corpus as a list of words. Okay, here they maintain all the words as the words and sentences, all those as a list of the words or a list of sentences sometimes, where each sentence is itself just a list of words, and we can optionally specify particular categories or files to read like this. Okay, some of them they are printed like this. Suppose it is A16. This is one file name here. That file name consists of the Society of Reporters. Suppose this one B02. It is related to editorial and reviews, okay, religion related, hobbies related, okay, law, bells, letters, government related. For all this, there is a file name, index, and its name. Okay, its meaning is this one. Okay, these are only some of the files text we use here. Almost there are 500 categories. You can see that. Okay, there is no repetition of this one. So A, B, C, D, F, so on. So with A, there may be so many. With a B, with a C, so many the text are there. You can see that one. Okay, by typing this. For this, you need to import this brown as from NLTK dot corpus import brown, import brown, so that the brown related entire files will be fetched. And then brown dot categories, here they, in the previous we use the field names, but here we are using file IDs in the previous one. Now we are using this brown dot categories. Those categories function gives you the total number of categories used in this, up to swan. Okay, so many are there. Adventure, okay, bells, letters, editorials, news, okay, fiction, government related. Under this government related, there may be so many text. In the same way, under fiction, there are so many. So under news, so many. So these are only categories, not the exact file names. So suppose if you see news of a of something, because it is showing a uh, indexed for news almost, right? B indexed for editorial. Okay, C indexed for reviews, like this. And after this, in A, there may be so many here. So those values, suppose A16 means CA16. It is a Chicago Tribune related news. That news will fetch in front of you as a list of words used in that file, right? So these are the categories, and from these categories, I am fetching some of the words used in this news category. Brown dot words, okay, from brown corpus dot words of this category. What is that category? It is a news category. In this news category, you can fetch it. That fetching is the full and so many are there. You can get this len of this brown dot words. Uh, I hope I did it in this collab. I'll show that. And similarly, brown dot words of the fields is equal to this. This directly without category, directly you can specify it, not the entire documents used in a particular category. Directly you can see the words from a particular category. So like this here, instead of a category of this news, I can fetch the words among this only this news article. Okay, Chicago Tribune. Just you give that name, that's enough. That file ID, that's enough to get all the words used in this. So here, the brown dot words field name is equal to CG22. C, I hope it is C22 stands for, where is that C22? It is not there. CG22. This is. Oh, okay. So based on this file name also CG22 is there. So based on this, you can fetch the words either from the category group of the documents or a particular document, like this. Now we can see this brown dot sentences. How many sentences there in the previous we used set it is for unique words used in that. Now it is a sentences. For sentences, fetching the number of sentences, use this dot sense. So sense of categories: news, editorial, and reviews. I'm considering three types of categories, not all. And from all these, what are the sentences used in this? This is one sentence, and this is another sentence, like this. So many sentences you can see from each one. So here for the news, for editorial, for this. And this generally the brown corpus is a convenient source for studying systematic differences between genres and kind of a linguistic inquiry known as, we call this one as stylistics. Okay, remember that. These stylistics you can fetch it directly using this one. Here I did it for you. Uh, it is web text. Okay, the web text did not discuss. So here from this nltk.corpus of input web text for file ID in web text.file IDs, print off this one. Okay, file ID comma web text dot raw of fields from 0 to 65 for each one. So these fetched for you from this web text corpus. Now, if you want to check this len of this one, you can see this len of this raw field IDs. And here you can import the next thing is nps underscore chart. This we discussed. And from this text, a particular data here, 10 already we discussed there. It is the chat room 123 consists of these number of words. And the len of this chat room consists of this 706 words. And here, now we are inputting the brown. The brown corpus consists of different categories. Okay, those categories we will see. Brown dot categories are these. These are the number of categories. Those number of categories. Suppose if you want to see the words in this news, you can get this one. You can fetch it as brown dot words of categories is equal to news. Now, if you want to see a specific one, you just see this CG of this one. And if you want to see the combination of the categories, likely you can give more than two categories at a time, so that this dot sense of categories, dot words of these categories also you can give it. Those sentences are this. This is the first sentence here up to this, and this is the second sentence up to this. Okay, like this. These are big sentences. And what is the length of these brown dot sentences of categories news? Under this news, how many sentences are there? So the total number of sentences used under this news are 4,623 number of sentences, right? Next is the length of brown dot sense of categories combinedly. Combinedly of these three categories, use this number of sentences. 9 3 this. Not only sentences, you can use the words instead of these sentences. Those can fetch the number of words used in the combined documents. All right. Anyone is there? Right. Now, here, we'll go this one. So what we call it as stylistics, about this linguistics. And here the you can import this nltk.corpus. Okay, import brown. And from this, the number of words you can fetch it, the number of frequency also you can fetch it. Okay, the number of words under the category news. Suppose if you want to see the frequency, how do you calculate the frequency? The frequency of the words. Okay, suppose I am denoting with f dish is equal to nltk dot frequency distribution is a function to get the frequencies of the words w dot lower for w in the news text. So what is news text? News text is created by me as news underscore text is my name, file name, list name. So brown dot words of category. So it fetches all these the words used in this category news. Now the models is equal to, suppose this is one. For m in models, you can print m plus of f distribution. so that you can get it 92 columns under this one. So there are a lot of operations generally involved in this, uh, varieties of the text. So here we've seen the general type of documents, and then web type of documents, and then the brown related documents, 500 documents, and there may be some of the numeric type and a special category type of text data available. On these text, you have to fetch different varieties of operations and their words and sentences and a particular searches of the sentence and so on. Okay, so now okay, this one hearting is going on. I'll come. Okay, I'm checking this attendance here. Tomorrow I hope tomorrow is holiday. Is it holiday?
Yes, sir.
Yeah, day after tomorrow you will have the lab. Where is this? Okay. Answer attendance number one. Number one, two,
Present.